which is a mock object library, and there will be a few words about TDD as well, because I can't talk about mock objects without mentioning test-driven development. So, a few words about myself. My name is Attila Magyar. Mostly I do Java programming, but I like dynamically typed languages like Smalltalk, Python, and others, and I have been doing TDD for about 4 years. I'm going to start with a quick and incomplete introduction to TDD, and then I will talk about BabyMock, and at the end there will be a short demo. Okay, so how does outside-in test-driven development work? We want to test and implement the functionality of this object A, and we start with a failing test case where we can send messages to this object. And let's say after the second message, it will do some computation, and it will send the result of this computation to another object B. But to do this, it will require the help of another object C. And the problem is that at this point, neither B nor C exist, but we can put mock objects in place of B and C, and we can set up expectations on them. An expectation is similar than an assertion, but it is against an outgoing message instead of a return value. And we can expect mock B to receive this message with this argument this many times, and we can allow the other mock to receive that message with that argument any number of times, and we can tell the mock how to respond to this message. And with these mocks, we can finish the implementation of A, and we can move on towards either B and C and repeat the same process. And we are keep repeating this until we reach the system boundary, where we can switch from unit tests to integration tests, but I won't cover these cases in this talk. And during this process, basically we are designing that messaging protocol between these three objects, the object under test, which is A, and the two peers, which are B and C. And some people call this inter-object protocol. So to put it another way, a mock object is a tool which can help you design that inter-object protocol. And BabyMock is a tool which lets you create those mock objects, and it is a visual mock object library. After each test case, it will display an animation about that protocol that I was talking about, and this can help people to get a good mental picture about the object relationships and the messaging, and it also makes it easier to identify test failures. Okay, the title of this talk is about BabyMock2. There is an older version. This is the old syntax. Looks like something like RSpec. We start describing an expectation by sending that should message to the mocks. So the first expectation is about receiving the time message by the clock, which is a mock object, at least once, and those two strings will be the return values. And there were some problems with this approach. There was no clean separation between the syntax and the core. It was not clear where the syntax ended and where the core began, so I decided to change this. And this also introduced some complexity because we are sending messages to the mocks. So, for example, if you want to mock the should message, you have to say mock should receive should, and this must be handled as well somehow. So this is the new syntax. Now we have an object called the protocol, which represents that inter-object protocol, and we are no longer sending messages to the mocks. And the main benefit of this syntax is that it is extendable or pluggable. You can replace the syntax or modify it, and you don't need to touch the core. From maintainability point of view, this is much better than it was before. And this is the same example. So we expect the clock to receive the time message at least once, and those strings will be the return values. And under the cover there are expectation objects. Normally you don't need to deal with them unless you want to extend the syntax, because the syntax creates these objects for you. This expectation is about expecting a message where the selector is that symbol. The argument must be exactly 42, and it must be received by that mock object at least 2, at most 5 times. Okay, so how does a mock object work? A mock object is a proxy which intercepts the messages, and there is a subscriber attached to this proxy which will be notified about these messages. And the easiest way to implement this is to use the does not understand, but it is a bit limited. BabyMock uses another technique. If you have a class and you set the method dictionary of that class to nil and you send the message to an instance of that class, then a cannot interpret message will be sent to the receiver, but the lookup will start from its superclass. If you are interested in the details, you can read that paper, but this is the important part. And what happens when we intercepted a message? This is BabyMock visualized with BabyMock. I'm going to show you an animation instead of this. So let's say we intercepted a message. Now we need to find the corresponding expectation to this message. And we tried the first expectation and it didn't match. Now we are continue with the second one, and the second one matched. Now we are invoking that expectation, and this invocation will provide us the return value, which will be sent back eventually to the original sender. And we report this message as an expected message, so the GUI will be notified about this, and we also reporting the answer. And at the end, we send back the result to the original sender. So this was the happy pass. What if there is no matching expectation? We intercepted the message again. We tried both expectations, but none of them were matched. And now we are reporting an unexpected message, and we are using this describe mismatch to generate nice error messages, and at the end we signal an exception which will cause a test failure. And the third scenario is here. After each test case, we need to check the expectations, and if any of them was unsatisfied, then we need to report a missing message and signal an exception as well. Okay. And the demo. I'm going to implement a shopping cart object and with outside in test-driven development. This shopping cart has 2 responsibilities. You can put items in it and you can do the payment. And there are 2 collaborators. One of them is the credit card, which is used to do the payment, and there is another one. I will talk about this later. And I prepared the recording because this takes less time. So this is the test case, the shopping cart test. This is the setup method. I created everything up front, but normally you don't need to do this. There are the 2 mock objects, and I created the shopping cart and passed the mock object as an argument. And on the last line, I enabled the visual mode by sending that visualize message to the protocol. And our first test case will be very simple. We want to test that after we created a shopping cart, it is empty. And how can we test this? We don't want to inspect the internals of the shopping cart. We don't want to provide access source to its internals. So we need to do something else. But an empty shopping cart behaves differently than a non-empty shopping cart. If I check out an empty shopping cart, then nothing will happen. And this is exactly what we can test easily. We start describing this protocol, and we expect that the credit card won't receive this charge message when I check out the empty shopping cart. So this is the first test case. And if you run this, we have a message not understood checkout. So let's create the checkout method in the shopping cart object. And I'm going to implement its body as basically an empty body. I won't do anything meaningful inside the checkout. And if I run this test case again, then this should be green. And as you can see, this is the object under test in the center, the shopping cart. And this is the test case. The test case sent the checkout message to the shopping cart, and nothing else happened. So there were no other interactions between the shopping cart and the mock objects. So this test case is green. Now we want to buy something. I'm going to put one item in the shopping cart, and somehow we need to translate the item into a price. And it would be good if there were an object which could do this for us. So I will introduce another mock called the price catalog, and I expect allow the price catalog to receive the price of message with this item, and it will return 25. So this line means that the price of that item represented by this item one symbol is 25. And this is called interface discovery, because the interface of the price catalog was driven by our needs. And here comes the real expectation. I expect the credit card to be charged with 25. And I put the item in the shopping cart, and this is the second test case. And if we run this, we will have another message not understood on the item. So let's create that method on the shopping cart. And I'm just going to store the parameter in an instance variable called item. I'm just assigning it to an instance variable. Now I put another breakpoint in the checkout because I want to check something in the debugger. And now I'm inside the checkout, and as you can see, we have the correct item. We can check its price with the help of the price catalog. And this printed out 25, and now we are confident that we can charge the credit card with this price. And by the time I press the proceed button, this test should pass. And it does. Those yellow arrows are because of the debugging, but if we run this test case again, then everything will be green. Let's step through it. I added the item to the shopping cart, then I send the checkout message. Now the shopping cart consulted with the price catalog about its price, and the price catalog told to the shopping cart that it costs 25, and finally it charged the credit card with 25. And this test case is green, but something bad happened with our first test case, which is now red. We have an unexpected message, price off. We asked the price catalog about the price of nil. And let's just put a nil check inside the checkout to make this test pass. And this nil check should check this problem. And now everything is green again. Okay, so far we tested the shopping cart with 0 product, with 1 product. Now we want to buy many products. There will be 3 products. Now I'm just copy-pasting those allowing lines to set up 3 different products. The first one has the price 25, the second one is 5, and the last one costs 10. And we expect the credit card to be charged with the total price, which is 40. And now I put everything in the shopping cart. And I rename it. And if we run this test case, this will fail. Yes, we charged the credit card with an incorrect price, which was 10 instead of 40. And this is understandable because we have only one single instance variable called the item, and we are overwriting its value. At first, I'm going to rename the items to items. And I will put it behind an accessor. And now I can use lazy initialization inside the accessor. And now I can replace the assignment with an add message. And the near check with an empty check. And I can wrap that price of message inside a collect block. I'm just translating the items to prices with the help of this price catalog. And the sum message is still missing, but I will put it there eventually. And here comes the sum message, and this should make the test green. So we are adding the items to the shopping cart, then we send the checkout, and we are asking the prices of these 3 items, and now we charge the credit card with the correct price, which is 40. Okay. And let's do some refactoring, because this translation is quite ugly. Let's extract it to a method called total price, and we can do some refactoring in the test case as well. This is what I want. I want to define the items and the prices in an array where each element is an association, where the key is an item and the value is the price. I'm going to create a prices method in the test which takes that array, and now I'm iterating over this array, and we expect the price catalog to receive the price of message with the key, and it will return the value. And this is working because if I send an unknown message to that syntax object, it will send back the message to the original sender. But you can put these prices outside of the expectation block and say self prices instead of this. And now everything should be green.
20 minutes.
Okay. And in the last test case, there will be 2 items and 2 checkouts. So I put the first item in the shopping cart, then I send the checkout message, and I repeated the same with the second item. So we have 2 purchases. And we are expecting 2 checkout on the credit card. And the first one was correct. Now let's add a new item and do another checkout, and this one will be incorrect. Instead of 5, we got 30, because we forget to clean up the shopping cart. But this is easy to fix. Just let's put a remove all at the end of the checkout, and this will fix this test. And there is another representation. This is the same test case. Yes. So that was the demo. And yes, I should give some credit to JMock, because many parts of BabyMock was inspired by JMock, which is a high quality, well-designed mock object library for Java. And the authors of JMock published lots of cool papers about test-driven development and mock objects and object-oriented design. So if you are interested in this topic, then I recommend this. That's it. Thanks.
Any questions? What did you do to make the drawings?
It's just Morphic.
It's Morphic?
Yeah. So the drawings uses Morphic. Nothing special.
Sometimes the test will be very long, and so running it may take, I don't know, 5 minutes. Are there ways to hide some part of the test and only focus the animation on some specific element?
You can step forward in the animation, and you can go to the end of the animation if you are not interested in everything. And you can check the log message only if you are interested on the result. And in the log message, there will be messages about which message was unexpected and which arguments were mismatched. Yes?
In this test, you, for example, you're defining which kind of messages are sent to the price catalog, and in this test, you're testing the shopping cart. Is there an easy way to reuse that information when you start to build a unit test for the price catalog?
Yes, this is a good question. In a statically typed language like Java, you have to use interfaces, and you describe the protocol using interfaces, and you can reuse the same information, and this will ensure that the test and the real object will be in sync. But in a dynamically typed language, you have to be cautious and pay attention to this problem. But normally, I don't think this is a huge problem in Smalltalk. Maybe in Ruby or Python it is a bigger problem, but we can use the ID, we can use refactor rename, and if I refactor, for example, a method on a real object, then it will rename. If I use refactor rename, then the messages in the test will be renamed as well. So
Because the selectors get renamed.
yeah, because of the selectors. Those are symbols, and Faro will find those symbols as well.
Okay.
Well. Okay. Thanks.
Thank you very much.